Morning students, welcome back to the online sessions of class 10, that's mathematics, that chapter number 3, that pair of linear equation. Now in the previous classes we were discussing about how we can solve the solution set of the linear equation, in which we have discussing the three methods. That three method includes which one? First one the substitution method, second is elimination method, and third one is the cross multiplication method. Now today the last method for this chapter we are discussing about the reducible method. So what do you mean by the reducible method? So first of all, we know that any form of linear equation that have the standard form of pair of equation, that standard form of pair of equation is generally considered as a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0. This is the true standard form of linear equation, in which a1, b1 and a2, b2 that is called as a coefficient of x and y, while the c1 and c2 that is generally called as a constant value. But how we can solve the reducible method? So in this equation, if we see that the form of denominator, there is no any value of the variable of x and y. So in a standard form of linear equation, we have been remove the denominator if there is any value corresponding to the variable of x and y. So if in a denominator, if the variable that consists the x and y as a form of denominator, how it can be removed? Generally in the previous classes we have discussed about the rationalization effect. How we can be rationalized? If the number which having a square root in a denominator, that can be rationalized by multiplication, or maybe numerator and denominator that can be multiplied by that number, which we have to be remove the denominator as a form of rationalize. So reducible method is just like that. Whatever the form of denominator is in a form of x, or maybe a y, or maybe x plus 1, y minus 1, square root of x, whatever the in a denominator. So before solving this type of question, if the denominator that consists the value of x and y is a form of variable, that you have to be removed, that you have to reduce, then you can solve this type of the questions. So in the reducible method, let me take the one example how we can be solve that formation. I'll take one example is here. For example, I'll take one example, 1 upon 2x plus 1 upon 3y is equal to, let me take 1 upon 2x plus 1 upon 3y is equal to 2. And another example, 1 upon 3x plus 1 by 2y is equal to 13 by 6. That two formation of the linear form of equation that should be given. 1 upon 2x plus 1 upon 3y is equal to 2. 1 upon 3x plus 1 upon 2y is equal to 13 by 6. So how we can be solve these questions? So first of all, whatever I told you in the previous form, that denominator that doesn't contain the value of x and y, if there is a value of 2 and 3 as a form of numeric value, that we have to remove by taking the LCM. But what about the value which is available in a form of variable? So if you see there, the variable which is available in a form of x and y, how it can be removed? How we can be remove the variable of x and y as a form of denominator? So let first of all, these two questions in a form of, so that denominator x and y, that first of all we have to remove, because we don't need the variable in a form of denominator. So that denominator we have to be removed. So denominator is what? X, and numerator is what? 1. So we have to suppose the value, let 1 upon x is equal to a, and here is 1 upon y is equal to b. That we have to suppose. Let 1 upon x is equal to a, and 1 upon y is equal to b. So now 1 upon x is equal to a, then a upon 2, the equation becomes a upon 2. So equation is a upon 2 plus here equation is what? B upon 3 is equal to 2. Similarly for the second equation, 1 upon x is equal to a, so a by 3 plus 1 upon 2y, it means b by 2 is equal to 13 by 6. Okay, these two equations in which we have to compare the value of 1 by x is equal to a and 1 by y is equal to b, so that we have to be taken as a form of a and b. So it should be converted in a form of a by 2 plus b by 3 is equal to 2, a by 3 plus b by 2 is equal to 13 by 6. So in this equation, if we see that there is no any variable in a form of denominator. Okay, so now we have to be compare or convert this equation in a standard linear form, because standard linear form doesn't contain the denominator value. So 2 and 3, that is a part of the denominator that we have to remove by taking the LCM. So LCM of 2 and 3, that will be 6. So by taking LCM of 2 and 3, LCM 2 and 3 is equal to 6. So making the balance of this equation, that will be 3a plus 2b is equal to 6 to the 12, because denominator is what here 1. So 3 and 2, 6, that should multiply, 6 1s are 6, then upper numerator 6 to the 12. Now here is what, that will be 2a plus 3b is equal to 13, right? 2a plus 3b is equal to 13. So now you will see that which type of equation is given, 1 by 2x plus 1 by 3y is equal to 2 and 1 upon 3x plus 1 by 2y is equal to 13 by 6. By reducing that equation, I will convert into the standard linear equation 3a plus 2b equal to 12 and 2a plus 3b is equal to 13. Now, how we can solve this equation? Now, before these three methods which we have to be studied in the previous class, like cross multiplications or elimination or substitution, that we have to be applied here. Any of three methods, you apply any one method for solving this equation, whatever for every z. So standard linear equation, that should be converted in a form of 3a plus 2b equal to 12, 2a plus 3b equal to 12. If you want to make elimination method, let me take the elimination method. So here is 3a, so that is multiply with the 2, here is the 2a, that is multiply with the 3 by taking the elimination method, okay. So 3 to the 6a plus 2 to the 4b equal to 12 to the 24. Now 2 3 is 6a plus 3 3 is 9b equal to 13 3 is 39. So this type of equations, 6a plus 4b equal to 24 and 6a plus 9b equal to 39. So making the balance of this equation, duster. So in these two equations, that 6a plus 4b equal to 24 and 6a plus 9b equal to 39, that can be balanced as a form of standard linear equation with the terms of variable a. So now here is the first equation 6a and the second equation is 6a, both are the same form. So we have to use the subtraction here, because same numbers having the same sign while using the subtraction sign. So here is plus, then minus, minus and minus. Eliminated. Minus 5b equal to minus 15. 24 minus 39 minus 15, minus and minus, that will be eliminated. B equal to 15 by 5. So B equal to 3. So value of B is equal to what? 3. Now that value of B equal to 3 applied into the equation number 1. So equation number 1 is what? That is 3a plus 2b equal to 12. So 3a plus 12b, b instead of value you have to take in 3, is equal to 12, right? So 3a plus 36 is equal to 12. So 3a equal to 12 minus 36. So 3a equal to minus 24. Then a equal to minus 8. So value of a is what? Minus 8. And value of b is what? The value of b is 3. Right? So equation is 3a plus 2b is equal to 12, in which we have to apply b, 12, 3 is not 2 is there, my mistake, here is 2b equal to 12. So 2b is equal to 12, then it should be 12 minus 6. 12 minus 6 is equal to 6, then a equal to 6 upon 3, then a equal to 2. So a equal to 2 and b equal to 3, we'll get the value of a and b. But we need to find out the solution set of x and y. So we have to find a and b, which have to be applied whatever the value we have to suppose. So now 1 upon x is equal to a. Now here, now 1 by x is equal to a. So a is equal to what? 2. The 1 by x is equal to 2. Okay. Then x equal to what? 1 upon 2. X is equal to what? 1 by 2. Similarly, 1 upon y is equal to b, then 1 upon y is equal to 3. So y is equal to what? 1 by 3. So answer is what? 1 by 2 and 1 by 3. So that is generally considered as the reducible method. So in reducible method, whatever the form of denominator which is given in a form of variable, that you have to reduce. After reducing, you have to convert it into the standard form of linear equation, and if after getting the standard form of linear equation, you will use any of three methods which we have to discussing into the previous class. It may be a substitution, it may be elimination, or it may be a cross multiplication. Whatever the method you can use to solve this equation. So that is generally called as a reducible method. Let me take another example for the reducible method, so that should be very easy for your understanding. I will change some of the form of question in a form of denominator as a part of the variables and the numerator values. How it can be solved, that will next discussing into the form. Next, I will take another example. 2 upon root x plus 3 upon root y. Okay, 2 upon root x plus 3 upon root y is equal to 2, and 4 upon root x minus 9 upon root y is equal to minus 1. So that will two questions is there, 9 upon root y. So in form of denominator, if we see that denominator is a form of variable x and y, but what? Square root of x and y. So entire form of square root of x and y which is available in a denominator, that you have to suppose, but numerator don't value, we have to take 1. So let 1 upon root x is equal to a and 1 upon root y is equal to b. That we have to suppose 1 upon root x equal to a, 1 upon root y equal to b. So here is what? 2 into 1, then 2. So 1 upon root x is equal to a, so it becomes 2a. So 2a plus 3b is equal to 2, and 4a minus 9b is equal to minus 1. So the entire equation is directly converted into the standard form of linear equation. Now we will take elimination method, whatever you want, they just make multiply with the 2, because here is 4a and 2 to the 4a, that should be easily balanced. So the first equation 4a plus 6b is equal to 2 to the 4. Second equation 4a minus 9b is equal to minus 1. Making the subtraction here, sign will be changed, negative, positive and positive. Eliminated. 6 plus 9b, that is 15b. 15b is equal to 4 plus 1, that is 5. So therefore b is equal to 5 upon 15. So b is equal to what? 1 by 3. So after converting into the standard form of linear equation, we will get value of b is equal to 1 by 3. Now b is equal to 1 by 3, which is applied into the any. So b is equal to 5 by 15, then b equal to 1 by 3. That b equal to 1 by 3, which is applied into the any one equation. So 2a plus 3 into b's value is 1 by 3 is equal to what here is 2. So 3 and 3 eliminated. So 2a is equal to 2 minus 1. So 2a is equal to 1, then a is equal to 1 upon 2. So let we get value of a is equal to 1 by 2 and value of b is equal to 1 by 3. Now but a and b, that will be what? 1 upon root x is equal to a, that you have to suppose, and 1 upon root root y is equal to b. So we have to apply the value of a and b in these values, and we get the value of x and y. That is your solution set. So now we have to apply the whatever the value we get a and b. So 1 upon root x is equal to a, and a is equal to what? That is 1 by 2. So root x is equal to what? Root x is equal to 2. But we need the value of x, so that square root will be removed from here, and moving on a right hand side, then x equal to 2 square, then x equal to 4. Similarly 1 upon square root of y is equal to b. So 1 upon square root of y is equal to 1 by 3, square root of y is equal to 3, then y equal to 3 square, then y is equal to 9. So you get the solution set x equal to 4 and y is equal to 9. So that is simple reducible method. If the value which is available in a form, so denominator which is available in a form of x and y. Now we will take another example which is available in a form of numerical value, how it can be solved as a form of numerical values, then how we get the value of x and y. So let's take one example here which is available in a form of denominator. We take a value of something x and y formation, then how we can be solved. So let one example we'll take here of one simple formation that phi upon, let we take phi upon x minus 1, simple one example. This is the form of denominator. Let phi upon x minus 1 plus 1 minus y by 2 is equal to 2. 1 minus y by 2 is equal to 2. And second equation will be take here 6 upon x minus 1, 6 upon x minus 1 plus 3 upon y minus 2 is equal to 1. 3 minus y is 3 upon y minus 2 is equal to 1. Then how we can be solve this equation? So simple formation, if directly we have to add up the value in a form of denominator. So denominator is what here, x and x minus 1. So we cannot be suppose directly x, because x which associated with the value of minus 1. So entire value of x minus 1 that we have to suppose, then it can be easily reduced from the denominator. So let 1 upon x minus 1 is equal to a and 1 upon y minus 2 is equal to b, that we have to suppose here. So it becomes phi a plus b is equal to 2. Okay, 1 minus y by 2 is equal to b, so that will be only b here. Next equation is what, 6a plus 3b is equal to 1. Okay, so first equation that become phi a plus b. Okay, b is equal to 2, and next equation is 6a plus 3b is equal to 1. So we'll multiply the equation 1 with the 3. We'll multiply this equation with the 3 for the balancing. So 15a plus 3b is equal to 6 and 6a plus 3b is equal to 1. Now 3b and 3b that will be easily balanced, both having the same sign. Then we have to apply the subtraction. 15 minus 6, that is 9a. 9a upon 6 minus 1 is equal to 5. 9a is equal to 5, then a is equal to what, 5 upon 9. So we get a value of a is equal to what, 5 by 9. So if we check the equation, first of all 1 upon 3 upon y minus 2, it should be a minus 3. Sorry, class sign mistake is there. Here is the minus sign is there. Minus sign is there. So 6a minus 3b, and it should be minus 3b. Okay, so then we have to use the addition method. 15 plus 6, 21a. 21a is equal to 6 plus 1 is equal to 7. 3b and 3b that should be eliminated. So now a is equal to the value of a, that is 21a. 21a is equal to 7, then a equal to 7 by 23, then a equal to 1 by 3. So value of a is what, 1 by 3. Now value of a 1 by 3, that is applied into any equation. So phi into a is what, 1 by 3 plus b is equal to 2. So phi by 3 plus b is equal to 2. So b equal to 2 minus phi by 3. 2 minus phi by 3. Taking the LCM here, b is equal to 6 minus phi by 3. So b is also 1 by 3. So a equal to 1 by 3 and b equal to 1 by 3. So now we have to apply the value of a and b from the equation. So 1 upon x minus 1 is equal to a, that is 1 by 3. So x minus 1 equal to 3. So x equal to 3 plus 1, then x equal to 4. We'll get the value of x equal to 4. Similarly, 1 upon y minus 2 is equal to b is what, 1 by 3. So y minus 2 is equal to 3, then y equal to 3 plus 2, then y is equal to 5. So we'll get value of y is equal to 5. So like this type questions in a form of denominator, we can easily find the solution set of x and y by reducing the variable of x and y which is available in a form of denominator. Let me take last example, reducing method. How it can be removed the multiplication value which is available into the form of denominator. How it can be solved in a form of denominator. That will take the last question for the reducible method. It is very easy. Just you have to be remove the variable which is available in a form of denominator and convert into the form of standard linear equation, and then you can be apply any of three methods which you have to study in the previous class. Next question will take another example, last example for reducible method. 7x minus 2y upon x into y. 7x minus 2y upon x upon y is equal to 5. Is equal to 5. That is the first equation we will take. 7x minus 2y upon xy is equal to 5. Next is 8x plus 7y. 8x plus 7y upon xy is equal to 15. 8x plus 7y is equal to 15. Now how can we solve this type of examples which is form of denominator entirely form of x and y? So first of all, here is the two terms 7x and minus 2y. This is the two terms there, and both term having the denominator x and y. So we have to write like this: x 7x upon xy minus 2y upon xy is equal to 5. Next 8x upon xy plus 7y upon xy is equal to 15. Then x and x eliminated, y and y eliminated. So remaining term is 7 upon y minus 2 upon x is equal to 5. That is equation number 1. Similarly, second equation 8 upon y plus 7 upon x is equal to 15. That is equation number 2. So equation will get 7 upon y minus 2x upon 5. So we have to suppose the value because denominator is what? X and y, x and y. So that will suppose let 1 upon x is equal to a and 1 upon y is equal to b. Let me take 1 upon x is equal to a and 1 upon y is equal to b. So therefore, here is 1 upon y. 1 upon y is equal to b. So first 7b minus 2a is equal to 5 and 8b plus 7a is equal to 15, right? So 7b minus 2a is equal to 5, 7a minus 2b is equal to 5. So let me take first a and then b. So therefore minus 2a plus 7b is equal to 5, 7a plus 8b is equal to 15. That is the second equation. First a and then is b. So now we'll take formation. We'll apply any of method. Now in this question I'll take cross multiplication method. Okay. So the right hand side value of constant that moving on a left hand side. So minus 2a plus 7b minus 5 is equal to 0. 7a plus 8b minus 15 is equal to 0. Okay. There is a standard form which converted in a form. So we have to use the formations by cross multiplication method. Then while using that a, when you write a, apply the value of 7, 8, minus 5, minus 15. When you write the value of b, minus 5, minus 15, minus 2 and 7. When you write the constant, minus 2, 7, 7 and 8. Okay. Now making the cross multiplication here, a upon minus 15 sevens are 105, minus sign instead 8 5s are 45, but minus 40 that becomes plus 40. Now in value of b, minus 5 sevens are minus 35, minus plus 15 2s are 30 is equal to 1 upon minus 16 minus 49. So therefore a is equal to minus 65, b is equal to also minus 65 and 1. So a upon minus 65, that is compared with the constant a upon 65 is equal to 1 upon minus 65, that gives you a is equal to 1. Similarly b upon minus 65 is equal to 1 upon minus 65, that also give you b is equal to 1. So a is equal to 1 and b is equal to 1. We'll suppose the value of what? 1 upon root x formation, 1 upon root x. So that will be compared with the value of a and b, because 1 upon root x is equal to 1. So 1 by root x is equal to a. So 1 by x is equal to 1, then x equal to 1. Similarly 1 upon y is equal to b. So 1 by y is equal to 1, then y is equal to also 1. So very easy formation, like when you use the reducible method, first things, whatever the value in a form of denominator of x and y as a form of variable, that you have to remove by taking as a formation of, suppose the value, it may be a numerator, you will get the value and convert it into the form of standard form. Then you can be easily convert that equation into the standard form of linear equation and get the value of a and b. So this is the last topic for a chapter number 3. When we are discussing the next chapter, which will be a formation of quadratic equation, which will be moving into the next lecture. For today's the third chapter, that will be over from here. 4 topics, that should be elimination, substitution, cross multiplication and reducible. Okay, bye.